In the following presentation, I will show you examples of objects that are in static equilibrium. These objects will be at rest, therefore being static, and they will have forces acting upon them that are equal and opposite in direction. Therefore, they will be in a state of equilibrium. The four examples that I will show you are of a ping pong ball floating in water, a Tigger hanging on a string, a person standing in room B7, and a human being pulling a spring from a screw. In this example, the force due to gravity is acting on the ball and giving it a downward pull towards the center of the Earth, while the force of buoyancy is resisting that force and is applying a force that is equal and opposite to the force of gravity. Therefore, since that force is equal and opposite, it is in a state of equilibrium, and since the ping pong ball is at rest, the ping pong ball is in a state of static equilibrium. The tension force of the rope is acting upward on Tigger, which prevents Tigger from further reaching the core of the Earth because of the force due to gravity. The two forces are equal in magnitude and opposite in direction, therefore they are in a state of equilibrium. Since Tigger is at rest, Tigger is in a state of static equilibrium. An upward force called the normal force is acting on this person. It is equal and opposite to the force due to gravity. Therefore, the person is in a state of equilibrium, and since he is still, or at rest, he is at a state of static equilibrium. An applied force is acting downward on the spring, and an elastic force is working upward on the spring. These two forces are equal in magnitude and opposite in direction, therefore they are in a state of equilibrium. The spring is also at rest, and therefore the spring is in a state of static equilibrium. These examples that I've shown you today all show the same thing, an object that is in static equilibrium. These objects are at rest, and they have forces acting on them that are equal in magnitude, but opposite in direction. Therefore, they can be said to be in a state of static equilibrium.